Hello and welcome back to my workbench. It is time once again to try to fix something. Today on the workbench I'm taking a look at another PS5 that is in dire need of some assistance. Now I picked this up from another shop and I know it has apparently has lightning damage. Some sort of surge damage, I'm assuming lightning damage because as it sits it's dead. It has a dead power supply in it and I knew that when I bought it. So yeah, first thing we have to do is swap out the power supply to even test anything, but I also know it has other damage. The person I bought it from did put a supply in it, and it did turn on and went to a white light, but it couldn't get any picture out of it, no video out of the HDMI. So there's likely some damage from the lightning on the HDMI port circuitry. The encoder IC, some of the Zeners, something in that area. It's probably also been knocked out. So I do have a working, 400 DR power supply, which I will put in there to test. But I will probably, if I'm going to take it apart that far to get that supply, I'll probably go ahead and take the board out and we'll take a look. Because apparently there may be some damage behind the Ethernet port as well, which is which is common if there's been a strike. It will knock out those resistors and capacitor behind the Ethernet transformer array in there. So well, let's get this thing broke down and see how bad it is inside. All right, well, I've got the board out of the chassis, ready to take a look at it. And I can already see some damage right here behind the Ethernet port, like was mentioned. So there could be some issues with our south bridge as well. But we'll cross that bridge when we come to it. Let's take a look at the microscope. We'll just go ahead and look at that area so you can kind of see what's going on. Yeah, right in there. That looks interesting, doesn't it? Trying to see if all that's showing up. See, we've got some traces blown off right here, which went to some test pads. So, yeah. And capacitor's blown up. This is a 1,000 picofarad, I think at 2 kilovolts. And these are 75 ohm resistors. And they're all going to be burned open. That's definitely lightning damage. So, it had a Ethernet cable connected to it. So we know we got that going on. But apparently, with a good supply, it will boot to a white light. So, it's not totally dead. Here we are behind the HDMI port, original port. I see a Zener there we might need to check. Let's look at the other side of the board around this encoder and stuff. Nothing's been touched in this area. Yeah, diode there. Usually what gets popped, if the encoder survived, these Zeners are going to pop, like this one here. And it seems like there's another one, maybe another side of the board, but there's some protection Zeners. Okay, let's do some diode checks looking into this port. How's that sound? Because I'm kind of curious what reads good, what reads bad. Red probe on ground. Pin 1. That's rather low. And that only goes to the encoder, so we do have a bad encoder. Like that goes through, well, it goes to those little ferrite filters right in there between the port and the HDMI encoder. But 2 is ground, 3 is also pretty much ground. No, it shouldn't be. 4 also shorted, 5 is ground, 6 shorted, 7 7 actually is not, that reads a little low. Actually, it should be like 8/10. Yeah. So they're not shorted. 7 and 9 are not shorted, but they're not good either. That's very shorted on 10. 11 is ground. 12. 13 looks normal. 14, no connection. 15 looks normal. 16, normal. 17 is ground. 18, that's probably about right. And 19, okay. So we just have a bad HDMI encoder. As far as no video is concerned, looks like. You know, something else may show up, but that's a good starting spot. So I'll replace this encoder. We got to make sure maybe we're not getting 5 volts out. We'll find out. That 5 volts handled by this switch right over here. So we'll make sure we got the 5 volts. I think we're going to have video after we replace this encoder. Then we're going to have to do some rework on the Ethernet connections, Ethernet port, those terminating resistors and that capacitor. Maybe fix a trace or two. Let's get some video first. Let me get set up for that. Well, the HDMI encoder has been replaced. I did have a new one on hand, so I put a brand new one on there. That seemed to go just fine. I did do some diode checks afterwards. It looked perfectly fine. Let's find out if we have any video now. I am very hopeful. Could be other things wrong. Oh, there we go. We have video. So just the encoder. All right, then that's good news. All right, we still have to fix the damage around the Ethernet port. And we still need to repair the power supply. That's my spare power supply in there. So we do need to repair that power supply when we get through getting the rest of this stuff straightened out. So, all right, that looks good. Let's take it back out and see if we can do some repair around that the Ethernet port. So we are back under the microscope, taking a look around this Ethernet port. And we do need to change out those 4 resistors. Those are 75 ohm resistors, sized 0402, and I thought I had some on hand, and what I have is 0805, way too big. So I will be pulling these from a donor. I do need to order some of those. and this 1000 picofarad 2 kilovolt capacitor. I'll be taking that from a donor as well. Let's get to it. Well, I have slipped the board back into the chassis so we can give it a quick check. Of course, we knew we had video. We're ready to check the Ethernet. So I ran a cable over here. Let's just see if we can get a connection. Maybe. Ready? LAN cable connected. Excellent. Connected. And it has an update. Of course it does. All right, so what we have left, Ethernet's working. What we have left is a dead power supply. So let's do that next. So it looks like we got the console itself working. If we can get this power supply going, so I can hang on to my spare. And again, this is the part of our program where I remind you to please do not open up your power supplies, as there are dangerous voltages inside that can harm you or kill you. So just don't do it. Finally. No roaches in this one, I do hope. Let's start off in continuity mode. Where's our friendly fuse? Right here. Are we open? Fuse is good. Okay, what about this fusible resistor right here? It is, oh, it's good. I thought it was going to be shorted. That's good. Okay. So if that's good, if that fusible resistor is good, then I would imagine these MOSFETs are going to be good. No short on the output. No, just some capacitors charging up. There's quite a few of them there. So, did we just kill our DAP056? That would be amazing. I don't see any burn marks, any scorch marks anywhere on this board, which was always a possibility with lightning. It could take whatever it wanted. All right, let's look at this DAP056 Let's see. Yeah, we'll look at it under the microscope because I know I've got an overlay there that comes in handy. I'm sorry, DAP053. That's 056. It's going to be the same thing. Let's go through this in diode mode. Go through this chip. Let me find a nice ground. That's got my scope in the picture too. It's a bit busy. All right, there's a nice ground right there. The negative side, one of those big filter caps. All righty. Can I manage to get this in focus? Pin 1 is right there. 0.7, 0.57. Look like it's in the ballpark. 3. That's not really in the ballpark I would expect. 4 is ground. 5, 6, 7's no connection. 8. That actually doesn't look too bad. 9 looks about right. Sorry, 10 looks about right. 11. Yeah, that's fine. 12, I think is no connection. 13.7. Yeah, that's fine. 14. 15. Nope. 15 should not be 0. 15 should not be 0. And then 16. So 15 definitely has a problem. And we had one over here that was also questionable. Which one was it? 2 or 3? Yeah, 2. Okay, 3 is showing 0.206. And I'm getting 0.6. So, but 15 is probably the one that's the most concerning. Where does it go? Because I don't remember. Is it going? Yeah, it's going there. Past that capacitor, then here's a Zener down here. Zener is reading short across it. So, yeah. Could be a bad Zener. That's ZD36. Marking of ZC. So the thing to do is to remove this chip and just see if that short goes away. Oop, that board popcorned. Maybe it'll go back down here in a second. Yep, a little too much heat there. They will do it. I'm just holding some pressure down on it, let it cool off. Okay. Now, is our short gone? Or do we still have a short across this Zener right down here? Yep. No, 0.7. So it's all going to be in the chip. Okay. Let's get a replacement IC on there. Yep, she popped up there on me. See if we can add a little leaded solder to this. All right, I think we're ready to test this. Well, after replacing that DAP053, I think we are at a point of checking. I've got several meters set up. This one metering across the filter caps. So that's metering the 395, 400 volts, whatever you want to call it. Across those, make sure that doesn't go too high. And this is metering the output 12 volts. And I do have a load connected to it back there, set for a 5 amp constant current. So I'm going to turn this voltage down. And I'm going to turn it on and start easing up the AC voltage. And let's see what happens on these meters. And she started. We started. And looks like I've got my leads reversed over here. Oh well. 12 volts, 12.1, 397, 398 on the filter caps. That looks fine. Yep, 5 amp current. All right. I think we are good. That looks all nice and healthy. So we just blew the one DAP053 right here. So, yep. They do go quite often in lightning. But luckily we didn't get anything else, looks like. So, all right, let me put this back together. We'll slip it in the chassis and give everything a full test. How's that sound? Well, this PS5 is fully reassembled with our repaired power supply. And she seems to be installing a game just fine. So the Blu-ray drive works. I've checked, it's not banned, so everything's good. I'm going to put a game in there and let it run for hours. Well, anyway, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.